have a, oh, thank you, Bjorn. Um, Today we have a very exciting talk by Riordan from LMU Munich about a topic that is of high importance on both sides of the ocean at the moment, the topic of consolidating quotes and trading accordingly. Ryan, thanks for your time and please take it away.
Great. Thanks, Andre. Thanks, Björn. Thanks, Katja, for the invitation. Thank you all for attending and joining me on my ski vacation. Here, I'm up at 3,000 meters with my PhD students and a colleague of mine and his students and some postdocs, and they had to leave the room to go and watch my presentation live because I managed to double book myself. So thanks to you all for coming. I will share my slides, and I'm going to assume that you can see them if I don't hear otherwise.
Yeah, we're good.
Great. Okay, so today I'm going to talk to you about a project that's near and I'd say dear to my heart. It's something we've been working on for the last, I'd say in stealth mode for the last couple of years, sort of more as an engineering exercise. And now that engineering exercise has turned into an economic exercise. And I think this is a good time for us to get the paper out there and get some feedback from you. So I'm really looking forward to hearing your questions. So I discussed with Andre and Björn and Katja. If you have questions, feel free to just to ask the questions, and if I feel like they're getting out of hand, I'll feel free to push them to the end of the seminar to make sure I get through the slides. And if you give me a couple slides to get warmed up and answer the basics, then we'll probably be more productive. This work is joint with Lisa Kaminski and Ralf Laschinger, and we're all, as Andre kindly mentioned, at LMU Institute for Financial Innovation and Technology. Yeah, there we go. So why this paper and why now? So I like to start either with a joke or with a quote, and this one I started with a quote. It's while the European equity market is less than half the size of the US equity market, it has many more exchange groups and roughly 20 times as many post-trade infrastructure products. So it's large, right? It's not twice as big, but it's half as big as the US equity market. It's not nearly as small as some people would expect, and it's different. And I'll talk a little bit in the next slide about how it's different. Another reason why now is a good time to look at the markets is, well, we actually don't have a consolidated tape in the EU, but a consolidated equity and bond and option tape is actually coming. So it's been mandated. The contract has been awarded. It was awarded in December of 2025. And so at some point we will have a European consolidated equity tape. And the question is, what is it going to look like? What is it going to do? And so what we're doing here is we're sort of putting together a first attempt at looking at what would a tape look like and what does consolidated data look like in Europe. Another reason is that we really lack basic empirical facts about European equity markets. How liquid are they? How illiquid are they? How much do they trade? What are market capitalizations? How many markets are there? Björn has a paper that's complementary to ours, looking at the US-EU liquidity gap. Of course, we cite it later, but also looking at these things. And so we think this is a really good time and a really interesting question or a set of questions to ask. Just as a brief, I guess, level set, there are differences as well between US and European markets, right? It's not, hey, we should look at European markets because they're large, but they're exactly the same as the US. In that case, we wouldn't really learn much. So how big are they relative to US markets? Well, 17 trillion versus 62 trillion. Well, in terms of market capitalization, they're a little bit smaller. But in terms of trading volume, they're only about half as small, 22 versus 42 trillion. And a surprising, and this is sort of maybe a first result from our work, is that effective spreads in Europe, and we're just looking at the largest stocks, but about 3.35 basis points relative, and Andre, actually, this number comes from one of your papers, to US effective spreads of around 5 basis points. And so on the surface, anyways, looking at S&P 500 or Euro Stoxx 50 stocks, actually European markets are more liquid and trade quite actively. Now, in terms of the structure of the market, the geography is also quite different. I got some maps later, so this is really just an overview, but the market geography is extremely diverse or dispersed in Europe. Right? The average distance between data centers is about 611 kilometers. Some of them are only 77 kilometers apart, and some of them are 2,600 kilometers apart. In fact, if we pick the ones that are farthest apart, we'd be in thousands and thousands of kilometers. Now, I realize that not all of the US market infrastructure is in New Jersey, but certainly a large proportion of it is in New Jersey. And this is all within 50 or 60 miles of each other. So Europe is extremely diverse, data centers all over the place. And so that's a difference. Regulation is a little bit different. We've got MiFID. MiFID 2 is sort of a big regulatory change in 2018, very similar to Reg NMS. This is really where we had competition across trading venues. We had MTFs, multilateral trading facilities. And so this had sort of a large set of change. Best execution in Europe is also different. So in Europe, market participants are supposed to take reasonable steps to ensure best execution, but it's not mandatory, right? A broker should try to get you best execution, but if they don't, it's fine. And on the other hand, there's no consolidated tape to compare it to anyways, right? There's no actual definition. Well, what is best execution? Is it the regulated market? Is it a consolidation of a number of markets? Is it the regulated market in an MTF? Well, in US, best execution is much more tightly defined. Yes, there are exceptions, intermarket sweep orders, some other exceptions, but it's relatively explicit in the US, and most trades in the US happen either at the best price or, as Andre showed in his paper, actually sort of price improved. And order protection is completely absent in Europe. So just because you're a market and you're posting the best price doesn't mean that you actually get the trade. Even if you're the only market posting the best price, you can be traded through and the orders can go to really essentially any venue. So there's no protection for the individual orders, and they can go anywhere. So the point I would say of this slide is that European markets are large and large enough that we should really care about, and they're different than US markets. So the questions that we can answer in these markets, I think, are relevant and important. We build on the literature. Of course, this isn't in a vacuum, right? We build on the market fragmentation literature, Thierry and Albert's paper, Maureen and Mao's paper, Hans' paper on fragmentation. And we sort of look at similar types of questions at a nanosecond level in Europe in a broad cross-section of European stocks. I'll get to the data in a second. We also look at execution quality and best execution. So this is in a line of papers with Bessenbender, Burma, Carol Cummington-Ford in her paper with Thales. We build on Andre. It's like it's your best hits here with your paper with looks like we've got one of Andre's papers. We look at sort of a number of papers that look at the speed and the access between individual venues and also market intermediaries. We look at European market design on sort of, we look at what is a tape going to look like? What can we do with the tape? How is this going to change things? And finally, a most recent paper with Jonathan and with Björn on the European liquidity gap. And we provide complementary evidence where we focus on the largest stocks in the set. And I think Björn, your paper with Jonathan sort of looks like at a much sort of medium size and smaller stocks. But our paper isn't in isolation, and we think we're building on these papers that have already done quite a bit. So I promised you at the start that this would be a little bit like an engineering exercise as well as an economic exercise, which is why I call them exercises. The first one is going to be to map out the European market infrastructure, just give you an idea about what we're talking about. The second one is we're going to reconstruct the EBBO, and we're going to do sort of a number of adjustments for latency and local and global depth that's available at each one of these venues and across all of the venues. We're looking at 10 venues. So we're looking at, and I've got the next slide, 10 venues, 50 stocks. These are the largest 50 stocks that are traded in Europe. It's called the Eurostoxx 50. I'm just going to say it's similar to the S&P 500, where, of course, really these Eurostoxx 50 stocks are more similar to the 250th stock in the S&P 500. They're certainly not comparable to the Mag 7 or some of the mega cap stocks. And we're looking across 5 years from 2000 to 2024. And at the very end, we have our more economic exercise where we're going to look at execution quality. We look at in exercise 2 quote quality, and exercise 3 we're going to look at execution quality in European markets. What's our data source? We have high frequency data from BMLL. This gives us trades, quotes, and these come from the direct feeds from the direct. Let me just close the Zoom window so I can see what I'm presenting here. These are our direct feeds and nanosecond resolution. We're going to take all of these direct feeds. We're going to build a sort of a global European best bid, best offer, Eurostoxx 50, 10 lit venues, 7 regulated markets, Xetra, which is the German market, Milan, Paris, Brussels, Dublin, and the 3 largest MTFs. And the way to think of an MTF is it's extremely similar to an ECN in the US context. So that's Aquis, CBOE Europe, and Turquoise. Everything is in euro, and this is from 2020 until 2024. Okay. Actually, that was maybe a good spot to stop if we have any questions. I noticed in some of the other ones we stopped at some places. Are there any questions up until this point? I know I haven't really got into results yet. If not, I will continue. So, for those of you in the US, this is a map of Europe. Okay. Here you can see the individual venues that we look at. We see the MTFs, which are in SLA, which is in London or just outside of London. These are our 3 MTFs. We've got any of the markets that start with an X are the regulated markets. And so these are the regulated market in the MiFID parlance is the former monopolist exchanges in each one of the individual European countries. So each one, so in Germany, it's Xetra, in France, it's Paris-Bourg, in Spain, it's Madrid. And so these are all of the individual regulated markets that trade and also list the Eurostoxx 50 stocks. And then we have here you see a number of exchanges. We've got XAMS, which is Amsterdam, Brussels, Dublin, Milan, and Paris. And this is where all of the Euronext markets are all located in Bergamo, Italy. And so these are extremely far apart, right? Helsinki and Madrid, 2,600 kilometers. I've got a slide that goes through all of these things. And you can just see the distance that has to be covered between a quote, a trade, an update. We're talking about sometimes 2, 3, or 4 milliseconds. Now up here in the top left corner, you see this little blue box. In this little blue box, the 56 kilometers, is where the 3 tapes in New Jersey, that's how close they are to each other. So tape A, B, and C. So all of the NYSE, MX, and NASDAQ listed stocks. So that's how close these venues are. Of course, there's other things, there's more infrastructure. This is just to give you an idea about the difference in geographic scale in Europe relative to the United States. Also, as a precursor, of course, latency is going to matter much more, or shouldn't say much more, but it's going to be extremely important in Europe. Here's some millisecond transmission latencies. So what we did here is we took a look at, well, how long does it take for a message in Basildon, which wasn't actually in the map. Basildon is where all of the Euronext data center was before they moved to Bergamo. So now they've moved to Bergamo in Italy. In the first half of our sample, they were in Basildon, also just outside of London. Halfway through, then they moved after Brexit, they moved all of their data center, their facility to Bergamo, Italy. So we've got the distance in kilometers, the milliseconds it would take for a message to go from Basildon to Frankfurt in a vacuum, in a fiber, right? Fiber is a little bit slower because there's some frictions in there. And we also estimate the empirical time it would take for something to get there. The empirical time is how long it takes on average, or an average minimum for a market to update to a trade in another facility. So if there's a price quote update or there's a trade in another facility, how long does it take for these prices to get reflected in a anyways at that individual venue. And you also see that we have an estimate based on how long it should take or how long it would take in a vacuum or in fiber and how long it does take. This allows us to estimate, and you'll see in the next slide, whether or not the connections between these data centers are actually microwave connections. And you see in a second, we've got this microwave triangle, or whether or not they're fiber connections based on how close the empirical update is to the fiber or to the theoretical speed that they can update. So here's the same map with distances between all of the individual venues, and you see this really thick line between the MTFs and SLOH, the Frankfurt venues. So we've got Cetra, which is the most important one there, and then all of the Euronext venues. So this is what we call the microwave corridor. So here is the core of the European market infrastructure. All of the connections are relatively tight, even though they are still far away in distance, but they're all connected by microwave. And still, even along this microwave triangle, we still have, from London to Frankfurt, we still have about 2.3 milliseconds of time for a quote update, for a price update to transfer. And this is going to matter later when we're reconstructing the EBBO. Okay, questions up until now? The next step is I'm going to explain how we construct the EBBO and give you a little bit of a sort of a preview of some of the results.
Ryan, are you able to see the chat?
Yeah. How does Bergamo London take less time on average versus how long it would be in a vacuum? Yeah, so that's a good question. So because we're doing an empirical estimate, it could have been that an order was submitted or orders are submitted to London at roughly the same time they're submitted to Bergamo. So it looks like one is reacting to the other when really it's just two orders that are being submitted at the same time. And so because this is an empirical estimate, we're going to have things that are moving at faster than the speed of light. And so that's moving some of these numbers down, but that's really just telling us that, a lot of these orders are happening sort of roughly at the speed of the light or a little bit slower than the speed of light, and this is part of our microwave. But it's really just an empirical estimation, and that's why we've got that number. But that's a good question. Okay, so what do we do? So we reconstruct an EBBO from all of these individual venues, right? That we just saw, these 10 venues with all of these sort of geographic dispersion. We've got different timestamps and latencies. So we create our synthetic European best bid offer from all of these individual BBOs. We create a relative EBBO that adjusts, and I've got the next slide that does it in more detail, the local BBBO for the time it takes for the data to get from the other individual venues. That means we're going to create a BBBO from the perspective of, and in this case, it's really actually data centers because all of the venues are together in the same data center, but we're going to give sort of a data center EBBO. How long would it take for the price updates in Cetra to get there? We're going to lag those prices to make sure that they're getting sort of what would the view of the world be from the perspective of the facilities that are located at that individual data center. So we've got an example here. So we just lagged the quotes from Frankfurt to Bergamo by 2.44 milliseconds, and that would be the quote that would be seen in Bergamo from Frankfurt at any point in time. We have 1.3 billion price updates, and we calculate venue-specific relative EBBOs from each data center's perspective for each one of the 1.3 billion price updates. And later, when we look at the trade quality, we're going to be matching 1.1 billion trades with these 1.13 billion price updates from the perspective of the venue that executed that individual trade. We do a number of other things. We take snapshots of the local, sort of the venue level, and also the global, so the European level, order book metrics. We look at depths, quoted spreads, effective spreads. I'm not going to give you all of the results. I'm just going to give you sort of the top line results. But yeah. Here's just a visualization of what we do is really, so if you imagine we're thinking about consolidating venue or consolidating data center, which would be Bergamo. We're going to lag the timestamps from everything that's coming from Cetra, right, based on what our estimated empirical time is. We're going to do the same thing for the MTFs from London. We're going to do the same things from Madrid. and we just didn't draw a line all the way from Stockholm. Sorry about that, Bjorn. But this is how we're going to be creating each one of the data center specific EBBOs. Now here's a first result. Once we create an EBBO and we take a look at the trades, we can actually calculate for the first time, I think for one of the first times, the effective spread for European stocks in Euro Stoxx 50. So we take a look at all of the trades that happen at these 10 venues. Yes, there are more than 10 venues. We're focusing at this point on 10 venues just for computational expediency, but also because these are the 10 most active venues. They do the most volume. And what are we plotting? The global effective spread in basis points from 2020 to 2025 on average across these 50 stocks. Here you can see, of course, we've got the 95th percentile at the top, the 5th on the bottom. And of course, we see a spike during the COVID crisis, a couple other individual spikes that happened throughout, a slow trending down, but I'd say from 2022 until about 2025, we've got a pretty good stable effective spread of between 3 and 4 basis points for all of the trades and all of these venues in the 50 stocks, which is, in my opinion, a fairly liquid market. And I see a question popped up.
Jim, would it be easier to unmute yourself?
Yeah, you can unmute yourself and ask, or I can read it.
Yeah, with pleasure. Basically, when you measure your spread measures, what minimum depth do you require? Is it 1 share, or is there a euro amount that because it can make a big difference on when you're measuring liquidity?
Yeah. So for the initial study when we're looking at, we're not looking at depth at all. But you'll see later, actually, we have filters for when we're looking at whether or not it's a best execution for, is there enough local depth and is there enough global depth? So when we're looking at, did something really execute at the best? We do take that into consideration in filters. You'll see in filter 3 and in filter 4. Here, in this, we're just looking at what was the execution price relative to the midpoint. But we do a depth adjustment in 2 slides.
Thank you.
Welcome.
Jose, would you like to unmute as well?
If not, I can just read the question out loud and then.
Okay.
Okay. Hi, this is Jose. How does your EBBO compare with the aggregated order book data generated by data providers like ALSEG or the old Thomson Reuters tick history? That's a good question. So the first time I presented this paper, I presented it in Stockholm when Björn invited me up to visit. His paper uses the ALSEG data, and we did a comparison, or we did at least a quick comparison, not all of the data, not everything, not the trade execution, but in some cases, well, sort of for a small subset of it. And the ALSEG data was similar, but not the same that we were getting from the BMLL data. So we have done a benchmarking, and the ALSEG is doing a relatively good job of putting the stuff in there. So I hope that answers your question. I'm going to guess. Andre, since I can't see the time, how am I doing on time? Was there another question?
We're good. We're about 25 minutes in.
Okay,
so we have another 25 minutes.
Okay, good. So I can take my time. Yeah. Okay, so this is the effective spread over time, and I think this is the first time series, and even on average, and I've got the average results in a second, showing that European markets, at least for the larger stocks, are relatively liquid. Now here is the sort of same set of results, but in just on average. The quoted spread is about 3.55 basis points. The effective spread is 3.3 basis points. And this is, we started to think about, and we are thinking about this more, and sort of how does competition to supply liquidity actually work in European markets? How many markets do we need, right, in order to in order to provide good liquidity. So on average, we have 4.7 or close to 5 venues that are quoting on average per stock day in one of the Euro Stoxx 50. So, 4 to 5, that's not actually that bad. We find about 2 venues on average are quoting at the EBBO, right? So usually there's 1 or 2 venues that are active at the EBBO. And so they're a little bit less competition, right? But, on average there are 2. And for the most part, not that I have results on this here, it's the regulated market that's going to be, so if it's a German stock, the Xetra, so the German stock exchange, they'll be quoting the best price quite often. And then one of the 3 MTFs, so the multilateral trading facilities, will also be quoting one of the best prices. So there is some competition, and when you get a little bit deeper and it's just at the best prices, there's a little bit less competition. So for me, one of the main takeaways is, well, European liquidity is a lot better than you'd think, right? If you just sort of listen to people talking how moribund and horrible the markets are here, well, they're actually relatively liquid and relatively actively traded. And compared to quoted spreads and effective spreads, I know we don't have a perfect example. I haven't rerun the TAC data myself, but taking some statistics, Andre, from your paper, and in some cases even looking at what the effective spreads would generate after price improvement, we're still looking at a market that's maybe at worst as liquid as US markets, and maybe on a good day even more liquid than US markets. And I was comforted not only that the LSEG data and the BMLL data were giving similar-ish quotes, maybe not the same, but similar-ish. But Björn also has a similar finding that for the largest European stocks, they're also more liquid than the largest US stocks. And then when you get into medium cap and small cap, that's where European markets don't seem to be doing as well in terms of liquidity. Okay. There's some other things that are interesting, at least from a market microstructure perspective. Well, we don't have order protection rules. We don't have bans on locked or cross markets in Europe, right? So you can have a market can lock or cross any market at any point in time. They don't have to remove the orders, or they don't have to reject the orders. So how often does this happen? So this is again on the stock day, on average over the entire sample period. So we have 17,000 normal price updates. So price updates for an individual stock on an individual day that are, where the ask is above the bid. We have 928 updates that lock. So one market has the same bid as another market has an offer, so would lock the markets. And there are 2,156 times on average again, where prices are actually locked. So that would be the bid price is actually above the ask price, right? So if we had, one way to think of this is if we had either a consolidated market, right? These could theoretically be trades that execute. You never know, right? It could be that HFTs are submitting these, wouldn't submit these orders in a consolidated market. But if we just sort of naively assumed we threw all of these orders together in a consolidated market, this would generate trades instead of locked and cross markets. Or if we had a regulation that banned this, then of course we would get sort of rid of these disequilibrium states. And so that, just breaking it down into roughly 90% or 91% of the time, we've got a global market, or sort of a normal market. 5% of the time, or 6%, we have a locked market. And the rest of the time we've got a cross market. Now, these aren't just in frequencies, these are also in seconds. So if you take a look, if you're dividing 928 by the sum of 17,200 and 2,900, you wouldn't get this. So these are in seconds. How long do these states persist? And that's still relatively long. So 5% of the day or 6% of the trading day, you've got locked markets, and 2% of the trading day markets are crossed. And so these aren't just milliseconds or microsecond crossing times. These are actually meaningfully long periods of time. Okay, I'm going to move into the third exercise where we assess execution quality. Any questions at this point? Have I missed anything? Oh, there are 2 things in here. Yeah. Jim posted something, doesn't look like a question, unless, Jim, you want to reformulate that as a question.
Uh,
And
Not really. I was just following up on my previous thing, and if anybody was interested, I had a couple of rants that I set off to our Securities and Exchange Commission, and thought some other people might be interested here. So sorry to disrupt the flow.
oh, it's okay. It's okay. Perfect. We'll have a look at those as well because part of what we're doing is also sort of thinking about philosophically, well, what should a tape look like in Europe, right? What is the, we can take some of the design lessons we've learned from the US and import them, but maybe not all of them, right? And also with best protection and with order protection rules as well, best execution.
Yeah, you should learn from our mistakes and not copy them, please.
Okay, we'll try. Okay, and there is a question here. Liquidity is not just tight spreads, though. Is there any metric you use to check liquidity field rates? It's a perfect segue into the next part of sort of the next part of our presentation, where we take a look at execution quality, right? So now we've built what we think is a really good or a relatively good European best bid, best offer. We've adjusted for latencies. We know what's there, and now we're going to try to see, well, how good are executions? So the first thing we do is we're going to match trades to the relative EBBOs. We have 1.1 billion trades in lit and continuous trading on our 10 venues. There are, just like in the US, there's a number of off-exchange trading facilities that we're not looking at yet. So they'll come in through things called systematic internalizers or approved publication arrangements, right? And so these are trades that are executing off book, and we're not looking at those, but we are looking at this point, anyways, all of the lit trades. We match each trade to the prevailing RBBO for that individual data center. So all trades that execute on Cetra are going to be matched to Cetra's RBBO. So we're going to look at Cetra trades. We're going to create sort of their view of the world at that point in time. We're going to lag all of the other venues. And then we're going to compare, well, did they get the best price on Cetra? Could they have got a better price somewhere else? We go through, I've got all of the filters here, but we go through sort of 4 filters. One, where we just sort of just naively look at this like, okay, well, hey, what does execution look like? We're not going to lag anything. This is our latency neutral EBBO, and this is just sort of assuming, everything is sitting in the same data center. There's no latency. What in a perfect world where, we didn't have any geographical constraints, what would execution look like? Of course, this is, an upper bound, right? We know that they couldn't actually attain these prices because of latency, but it's just going to give us sort of an idea of what would happen if we mandated all of the data centers to sort of be in one location. It's not going to happen in Europe, but what would the world look like if we did it? Yeah, and we're going to do all sorts of individual things, but the biggest thing we're going to do is we're going to look at slippage. So how often do we not get the best prices, and how much does it cost in terms of, I said welfare losses. Peter sent me a message and said, hey, well, they're not necessarily welfare losses, it's redistribution. I'm going to agree with that, but how large are the slippage costs? We do 2 other things. Jim, this was sort of, you preluded this. We're going to look at, well, whether or not there was even local sufficient depth, right? So was there enough depth available on one of the other venues, and whether or not there was enough global depth in order to execute something. So we're not going to be pulling in prices for a trade for 1,000 shares and say, well, they could have got a better execution on another venue, but on that venue there's only 1 share available, right? And that would be the third filter. And the fourth one is, well, was there even enough liquidity available at the best price if they split up their trades amongst all of the venues that we're quoting at the best? And so this is going to give us, I think, sort of a least conservative estimate where we throw everything together, and the most conservative estimate where we're looking at, well, could this trade have been executed if it was routed properly across all of the different venues with all of the different sizes. And so this table is our execution quality, where we decompose it by filter. We have sort of 3 states. One is a trade is executed at the best price, so it really gets the best price it could. It's improved, or it's worsened, meaning it gets a price that's worse than the best available price. So if we take it latency neutral, everything's sort of bundled together in one data center, 81% of trades executed at the best, let's just say effectively 0. get a price improvement, which is a stark contrast to the US, and 18% get worsened. I'm not going to go through all of the individual columns, but if we shift to the final column, which is our sort of our most conservative, where the has to be enough liquidity available on all of the venues that are quoting at the EBBO in order for us to sort of classify it. 86% of trades get the best available price, still roughly zero, are improved, and 12 or 13% of the trades actually get worsened. So here I'd say that while European markets have pretty good effective spreads, they don't seem to be well executed or sort of well integrated in terms of executing orders at best available prices. And we don't have any evidence of this yet, but the suspicion is that most of these orders that are executing at worsened prices are probably not the HFTs, they're probably not large institutions, they're probably not sophisticated investors, they're probably retail investors that are using some of the neo brokers. And so these losses are accumulating, let's not call them losses, but these, the slippage is accumulating at the least sophisticated investors. We break the same sort of 4 filters down, and we report the statistics for all of the individual venues. I'm not going to go through each one. What we've done is we've clustered the MTFs. I know we said we have 3 MTFs, but there was sort of a move in between. So in this case, we have a couple more. The MTFs execute 80% of the time, or 87%, or almost 89% of the time at best available prices, and the regulated markets at 86%, so a little bit less of the time. And this really tells us that even when an MTF is the best, an regulated market is still more likely to actually receive an execution, because these markets receive executions 85% of the time when they're the best, which also tells us that about roughly 14% of the time they're getting trades when they're not at the best available price, where MTFs are only getting about 12% of the time. So it's not a big difference, but regulated markets are more likely to receive an order even if they're not quoting the best price. I saw a question pop up there, I think. Okay, hi Phil. Can you tell if the worsened fills are where prices faded on microwave while the order was traveling on fiber? That is a good question. I suspect we can tell if that's the case, but I don't have an answer. I don't have an answer for you on that. It is a good question, right? If something could have been coming in through microwave, but then it was traveling actually via fiber, wasn't using the microwave. So what we could do is we could lag some of the prices even more. We could sort of see, how long is it? 5 milliseconds? Is it 10? Is it 15? When do these disappear? Or do these executions disappear ever? Phil, hopefully that answers your question, but if not, I'd be happy to. And Björn has a question. Björn.
Yes, slightly related. Your improved statistic, so there is no price improvement in the US sense here. So do you interpret that as a measurement error, or is it hidden liquidity, or what do you think?
Yeah, so it's probably mostly hidden liquidity. So executing against iceberg orders or some sort of hidden liquidity. Now there are some markets. Tetra, for instance, has it. Paris Bourse in Paris. They actually do have price improvement facilities. They're just not used very often and don't seem to generate a lot of meaningful price improvement. But one of the next things we're going to try to look at is trying to find venues, types of execution facilities where we would expect to see price improvement, and see if we find more of it. Yeah. So
okay.
I suspect
is that a retail mechanism at Tetra?
Yeah, so there's a retail price improvement mechanism at Tetra. There's also retail liquidity provider facility in Paris. There are some exchanges that we haven't added to this, but we're going to start adding some of those trades at some point, where they only execute retail trades and could be offering price improvement. Maybe they are, maybe they aren't, but yeah, this is something we're actively working on.
Thanks.
Welcome. Okay, Andreas, your guess not receiving the best could be a data issue in the sense that the sender actually did not consume data from from the better pricing venue. Yeah. So one of the I think you're spot on. What we think in some cases that brokers are just connected, for instance, to the regulated market, or are only connected to regulated market, and perhaps one of the MTFs. And if they happen to be, not connected to the MTF that has the better price, then they're just going to miss it. So you're right. We're not assuming any malevolence or that they're trying to not get the best prices. I think a lot of it is just going to be a connectivity. And I know everyone hates policy prescriptions, but I think this is a really policy prescription, potentially heavy paper. One of them, you could just sort of mandate, well, brokers have to be connected to X number of venues, or, any venue that trades more than Y, or any venue that's quotes at the best more than X, whatever it happens to be, just to sort of get rid of some of these data issues, or I'd say connectivity issue, but yeah, data issues. Jim asked, do we have all the off-exchange trades? Yes, we do have them. No, they're not in here yet. So they get reported in I'd say, opaque and sort of obscure way. And so it takes a while for us to scrape them. The other issue is that it's unclear from some venues and just in general if the timestamp is actually the time that the order was received, the time that the order was executed, or the time that the order was reported. And so trying to then match to a microsecond EBBO, we have to be really sure about what we're matching if we want to make sort of any inference about improvement or disimprovement. So it's, again, something that we're actively doing, but just timestamps are an issue. Here, these are all centralized limit order books, and we know sort of when you get a trade timestamp and a quote timestamp, what they actually mean. Okay, so here's essentially the sort of the same evidence, sort of in a waterfall perspective. The one thing we're adding here is the right figure, which is the absolute slippage in euros. I've got all of this again in a table in the next slide, so you can see it. But here we've got our 4 cases. We've got case 1 where everything's in the same data center. If we assume that we put everything into the same data center and that there was sort of no latency, we'd be looking at an annual slippage cost of about $500 million. If we adjust it, surprisingly, actually, the slippage gets worse, goes to about 750 million euros. When we adjust for local depth, meaning, okay, but, we're looking at venues that could only trade 1 share for trades for 1,000 shares, well, then we lose some of it. The same for the global sufficient depth. And we end up at roughly 50 million euros a year of slippage. Again, we're only looking at these 10 venues. There's all sorts of other venues, and we're only looking at 50 stocks, but that's essentially what we get. So roughly 250 million euros of slippage over 5 years in these 50 stocks. Here's a table that sort of highlights how large or small the worsening or the improvement or disimprovement is. In the middle is the number of trades and the number of shares that are executed at the best, right? So this is our 86.49%. So this is our most restrictive filter. And if you see, so roughly half of the trades, or sorry, not roughly half the trades, roughly 11% or most of the trades, their execution price is only 0.5 cent worse. I didn't talk about it too much, but there's a smart tick size regime in Europe, so where tick sizes can go anywhere from, I think the smallest increment on anything trading over a euro is 1/10 of a euro cent, all the way up to 5 or 10 actually euro cents. So they're worsened by about 0.5 cent, so very, very minimal, right? So this is a trade that, something is trading at 10 cents and it's only 0.5 cent, or sorry, 10 euros, and it's trading 0.5 cent off. So very, very, very small amounts of slippage. 1% of the time it's worsened by up to 1 cent. And then after that, there's very, very, very few sort of cases where it's sort of 5 cents or 10 cents more. So this is really minimal slippage, really small differences in execution. And I mean, here you see there's almost no meaningful price improvement. We do the same thing in ticks, just to sort of highlight the point I was just making before, but around 8% of the time it's worsened by 1 tick, which makes sense. 4% or 5% roughly of the time up to 5 ticks, and very infrequently something that's that executes at more than 10, 20 or more than 20 ticks. This was also for us a sanity check, right? So we would expect a distribution that looked very similar to this, right? If we were, I think, doing a good job. So prices aren't executing, but they're not really, they're not executing at the best available prices, but we're not talking about 10 or 15 or 20 cents off. It's, if something isn't executing at the best price, we're really talking about 1 tick or 2 ticks away, and where the case is still important for an individual investor, but we're not talking about sort of massive slippage costs on a per trade basis. Just as a final sort of results slide, what determines best execution? I think this is what we'd all expect, right? 77% of the time, we're going to get best execution. For every 100 kilometers away, we're going to get a 1% lower probability of actually receiving execution or best execution. So the further away I am, it could be that, well, hey, maybe I could route my order there, but by the time it actually gets there, maybe I don't actually get the best price anymore. And so I'm going to execute it locally. Well, I really could have got that price. And so no, that's what we see. We've got more venues quoting it the best. We're more likely to get best execution, which makes sense, right? There's just more venues that could possibly execute my order at best prices. So we would expect this to be positive. The larger the trade, the less likely it is to get best execution, which also makes sense. If I have a really large trade, I might want to execute it quickly. I might be, submitting multiple large orders across multiple venues. And so I'm just going to be less concerned about 1 or 2 cents that I'm missing or a couple ticks if my trade is extremely large. Midpoint volatility, when prices are more volatile, I'm also more likely to or less likely to get best execution because, well, prices are just moving a lot, right? And so, price could move just as I'm submitting an order. I don't get the best execution, or I'm just more worried about getting something executed than I am about whether or not I'm getting it 1 tick or 2 ticks better or worse. Finally, you're more likely to get a best execution if you route it to an MTF, right? So if I'm executing an order, I shouldn't say that if you're routing to an MTF. When you route it to an MTF, it looks like conditional on routing it to an MTF, I'm going to be getting better execution than if I submit it to a regulated market. And particularly, we find the worst execution quality is when orders are being routed to a regulated market that isn't the listing market. So it would be, I'm trading German stocks on the Paris Bourse, right? So I'm not sending it to an MTF. I'm not sending it to the German regulated market. I'm sending it to one of the other regulated markets. And that's when you get most of the sort of the slippage, or the least likelihood of getting the best execution. Okay, we are almost done. I'm ready for some questions. I would say there's some differences in European markets between available prices, which actually look quite good, and attained prices, which I'd say on the whole aren't horrible. I mean, there's just a lot of executions that are just 1 or 2 cents off. European markets are liquid. Some investors are able to access liquidity at this venue. And in contrast to the US, there's no meaningful price improvement, at least not in the 10 venues we're looking at. But we are sort of looking at this sort of more broadly. So markets aren't illiquid. They're just in some cases poorly connected. Consolidation is, really important. I didn't show you the differences between the venue level statistics and the aggregate, but have spreads, it triples depth, it reduces slippage. Welfare loss, 250 million. You can think that's high or low. It's up to you. And I guess at the very, very end, got a couple of points about whether, tape, is it good or bad? And do retail disproportionately suffer? The last thing I'd say, not in my paper, but just something I'm gonna throw out there as an observation. Top 3 journals are filled with U.S. microstructure papers, yet there are very, very few written on Europe. So we remain largely unstudied. And despite the fact that it's extremely large and there are really meaningful regulatory differences. So I think there's a lot of things we can learn by studying European markets. And I hope that, I hope we can continue the study. And thank you very much, first of all, and looking forward to questions.
Thank you, Ryan. We have 3 raised hands. Let's go in order. The first hand was by PEF Stat H.
Hello, this is Peter Staffy from the London Stock Exchange. So very interesting presentation. Really, very topical for us, of course, because London is going through the debate as to whether we introduce a consolidated table or not. So very interesting. And but of course, the London Stock Exchange, we both are one of these regulated primary markets. So we have the Exelon, we are an X, and then we also have turquoise. So we have an MTF as well. And so I was really interested in your statistic that showed that trading on a MTF results in significantly improved probability of achieving best execution. And I was wondering actually how sensitive that was to your latency calibration. So if you bumped your latency by a tiny amount, would you observe that shifting significantly? And my intuition as to why that would probably be the case is that I imagine a lot of the time what's happening is there's latency arbitrage occurring. So the price changes happening on the primary, the signal is racing to the MTF and being picked off there. And if your calibration is maybe a little bit off, that might be what's driving this, that they appear to be, your sort of the state of the LSE book or the state of the primary market book looks, the primary market book has moved, but maybe your trade hasn't yet occurred on the MTF, but it will do in an instant.
Yeah, it's a good question. So we do have in the appendix, what we do is we do look at how sensitive our best execution statistics are to latency, right? So if we look at it's not the 2 milliseconds, it's 3 milliseconds or 3.5. So we do look at that sensitivity. I haven't looked at the sensitivity on the result. You were just sort of interested in whether or not you're more likely to get a better price on an MTF. Based on the latencies. That's really a good question of what other results could appear or disappear based on, right? So one of the questions was about, well, what if it's, you're assuming a microwave connection, but the order came in via fiber, which is just sort of adding another millisecond to that, or, is there just a little bit off in terms of our calibration? And is this really some sort of an arbitrage and not really a missed execution? So those are good questions and things that we have to. I think it's more where this paper gets into the engineering exercise. Of course, then if we have an economic exercise, but yeah, those are things that we can look at. And I'm happy to chat on how you think what you think a good way to sort of test that assumption would be. I mean, besides just lagging venues a little bit more. The problem is the more we lag things that, at some point we're just going to lag and we're going to have no results, right? Or we're just going to start leading into other things. So it would be interesting to know what you think a good way to test that would be.
Definitely, yeah, we should talk. And indeed, one of the things we've done a bit of analysis on our side where we've looked at exactly this question as we adjust these lags. And then, of course, the thing is, we have the data for when we actually do observe changes in the book. So, yeah, we should definitely talk.
Great. Okay. Look forward to it. Yeah, long time no see.
Yeah. Thanks, Ryan. Nice talk. I couldn't agree more on the point about bringing on more papers on European equity markets. I liked your map that really shows this difference in how close together the US markets are and how dispersed geographically the European markets are. So I don't remember if we talked about this before, but do you know what is the economic mechanism that lead the US markets to, they seem to want to be very close to each other, their data centers, whereas the European markets, the exchanges seem to push their data centers out in the periphery. When Euronext moved their data center to Bergamo rather than to Amsterdam or Paris, and now SIX have their data center in Madrid instead of Zurich, Nasdaq are in Stockholm instead of Copenhagen. They don't want to be close together. Do you know why?
Well, I thought your question was going to go in another direction, right? And the easy answer to that one would have been sort of the individual countries want to have a regulated market in a capital city or close to it. Now, the exchange groups wanting to co-locate makes sense, right? They want to put all of their markets together, but why they want to co-locate their individual markets so far away from each other, I don't actually have a good answer for the question, but Jim might be able to say it better than I. But I mean, I think one of the reasons that a lot of the tape infrastructure ended up in New Jersey is just because sort of New York was the center of equity trading with NASDAQ and Amex, and so that's probably why they just ended moving up. There was something a little bit cheaper, still relatively close, and why they ended up there. But why NASDAQ ended up in Stockholm and Euronext in Bergamo and SIX in Madrid, that's an interesting question. And there's probably a bunch of people on the call that have more insight than I do.
Yeah, basically what you just said, Ryan. But it really comes down, in the US, I think it came down to the liquidity externality, in that for the newer exchanges and the rival exchanges, you basically want to be where your customers are. And if they're in NY4, well, you can locate an NY4 just like they do. And so they have shorter distance to get to your servers. So there's definitely a gravitational pull towards centers of liquidity. But there are also other commercial things to consider, such as distance to your headquarters, where you get, you can find good data centers and so forth.
Lower taxes as well.
Yes.
PK.
Yeah.
Thanks, Jim.
Yeah, thank you. Well, having worked on the international markets, really very ambitious exercise. So congratulations on putting this all together. I know it's a lot of challenge to work with so many different country regulators and so on.
Thank you.
So it's amazing that you have, even in with the lack of regulation, so much best execution already happening naturally, right? So that speaks a lot to the competitive nature of markets, I guess. And but is there also other features, like you gave an example of German stock trading on the Paris board? I mean, how will that happen? Isn't there settlement friction there? Like how do these stocks settle when they trade in these different locations?
Yeah, so they're essentially across, so MTF or MiFID II sort of ensure that there's settlement across all of these individual venues. So it's fungible. It's like working in a Reg NMS system. If I trade anywhere on any of the regulated markets, or one of the venues, the APAs or the SAs, they're all going to they all sort of get settled in the same infrastructure. Now, there are some costs associated with that infrastructure that aren't really germane to what we're doing. It's not one settlement infrastructure, but there is some sort of cross infrastructure settlement that happens in some cases. But yeah, essentially a stock purchased on an MTF and then sold on Cetra is fungible across that.
Oh,
and it wasn't before.
Yeah. Okay, thank you. That's good development. Okay, thank you.
All right. We might have run out of questions. Ryan, unless you have something else you wanted to share.
I think I should ask you guys some questions
about your paper.
No, I mean, I think I would just say, what this is a paper that's relatively new. I think this is one of our first sort of big presentations of it, and we do intend to sort of extend it into other areas as well, sort of looking at more of these systematic internalizers, APAs, more stocks, smaller stocks, really looking at some of these other questions that have been brought up. So this is I'd say first, I don't want to say a series of papers. It sounds silly, but sort of a first paper looking at hopefully just sort of European market microstructure more broadly. But I don't want to talk too long because I think two people have questions. And Stefan, I agree with your comment. I agree. It doesn't seem like much, and most of the slippages in the cent are the one tick. So I was much less concerned after I saw that. Peter, I think you got a question. I've got two Peters there, I think.
Two Peters.
Peter 1.
Okay. I think from my research, it transpires that not only the time of propagation of the signal along the trading network, but also the dispersion of this time. In a simpler example, it could be the signal going from, say, Bergamo to Helsinki through Frankfurt by microwave can run to Helsinki in approximately the same time as fiber optic signal from Bergamo directly to Helsinki. And so the dispersion of this time can be pertinent to the action of the network.
Yeah, so I think what you're referring to is latency jitter, right? So not just the average latency, but the variance around the latency, right? And so how sure can I be if I route something that it really is 1.4 milliseconds or 2 milliseconds and not sometimes 3 and sometimes 1. So you're right. In fact, I got some of those questions. I think Stefan had mentioned that, and a couple other people had sort of said you guys should think about the jitter, right? How much variance is, and some of these, right, especially the fiber lines are going to be much more jittery than some of the microwave connections. And there's also the secondary question is, well, we're assuming that everyone that's trading in the microwave corridor is using a microwave, but a whole bunch of people might not be using the microwave because it's more expensive. So they might be using fiber, which could also be generating some of our results. So that's sort of the heterogeneity of the latency. So that's a good point. Thanks, Peter. I've got another Peter, and then I've got a Dale.
Yes.
So if I just so you mentioned systematic internalizers. Since you're using BMML data, they do have some of the systematic internalizer quotes. Again, we've looked at it, so in our chat we should definitely talk about that because it is super interesting, as well as you reconstruct an EBBO using SI quotes, how much additional volume you appear to unlock and how much additional price improvement you unlock as well. Super interesting.
Yeah, I would love to talk to you about that. The roadblock is really just sort of understanding what the timestamp means on SIs, whether or not it's what we think it is. And if it is, then we can use it. But some of the SIs seem to operate differently than others. So
it's a bit of a pain.
It's a bit of an institutional detail that we haven't quite figured out how to tackle systematically.
And actually, as you start on this project, you should also lobby BMML. They currently don't make the Trade Echo, which is the LSE's APA systematic internalizer quotes available through the security API. You only get access to the SIBO one. So I've asked them to do it. They said they need more clients to ask for it. So
okay, I'll tell them. The next time they want money from me, I'll just say, hey, if I don't get Echo, then
you don't get Echo. What's the point?
I'm just going to drop all of my papers, and then I'm not going to subscribe.
Yeah, okay, exactly. Definitely.
Dale.
Thank you, mate. Appreciate it.
What was that Echo again?
The LSE Echo. Echo. Dale, I think you're our final question.
Yeah. I was going to say, so I definitely agree that jitter can be kind of crucial. I've sort of done work with that even in US markets where you get some, but I always worry about sort of aligning clocks, especially over this kind of a geographic dispersed region. So I wonder if maybe you could look at your locked and crossed markets and see if there's sort of slight shifts that might increase or decrease that. But also, when you see that, does that then lead to, is that sort of predictive of sort of some of your next trades? Because if it is, that's definitely a sign of jitter, maybe that, is going on and the market's acting on it. So that might be a way of sort of getting out of the whole clock alignment game and just sort of getting some measure of how much jitter there is out there.
Okay, yeah, that's a good sort of, instead of thinking about light in a vacuum, we'll just sort of think of ways to estimate this empirically based on what we think people are going to do in terms of arbitrage or sort of trading. Okay, that's a great point.
All right. Well, thank you very much, Ryan, for this exciting and informative presentation. Thank you all for coming. If you are here 2 weeks from now, we're going to have Xiaozhang Wang from Wharton talking about China walls. So we would like to welcome you back for that. And I guess we're done for today.
Thanks, everyone. I appreciate it, especially all of my co-authors I see out there. And of course, everyone else, but also my co-authors. Thanks for coming. Bye-bye.
Bye-bye.